5 to 7 inches of insulation room. When we put in blown in insulation, again, it's about R3 per inch. So if we have R60, we need 20 inches of space there to achieve that full R60. Wherever the heels of the trusses are, you only have 6 or 7 inches, and as a result, you only have about an R20 or 25 there, and it's going to take you 3 to 5 feet in from that heel before you can develop that full R60. So you should really be looking at some other styles of trusses or heels of trusses to achieve that higher insulation for more of the area of the ceiling. Why do we put more insulation into the attic than we do into the walls?
Heat rises.
Heat doesn't rise.
It's easier, it's cheaper.
It's cheaper because we've got the room to do it. Heat goes equally well in all directions. Warm air rises. And so the heat loss through a square foot of ceiling is the same as it is through the wall. Because heat goes equally well in all directions. It's just that it's much easier to put an R60 in the attic than it is to make an R60 wall. We'll talk about this house a little bit later here, but the reason we have more insulation in our attic is just because it's so easy to do. We simply go up there and we just blow it in. And we got all sorts of space to do it, whereas in our walls, that's why we went to 2x6 framing in our walls. Back in the 70s, and even into the 80s in some cases, we typically build walls with 2x4s at 16 inches on center. The only reason we went from 2x4s to 2x6s is so we had more depth to put more insulation in. We don't need it structurally. You can build a 2 to 3 story house with 2x4s.
24-inch centers.
At 24-inch centers for that matter, exactly. So we didn't do it for structural reasons, we did it to increase the cavity depth that's there so we can put more insulation in there. And so to go to 2x8s or 2x10s for exterior walls is really, that doesn't make much sense. So if we want to get more depth to put more insulation into our exterior walls, we need to look at some other systems, either double stud wall or staggered stud or other systems that are out there to increase the R value in our walls to reduce the heat loss that's going through there. Okay? So again, we want to look at high levels of insulation in our attic, and it's easily done there because we've got the space to do it the way we typically do our houses with truss construction for the most part. Number 9, Energy Star windows and doors. Again, the federal government through their Energy Star program has developed standards for windows and doors, and there's 4 zones for them across the country, A, B, C, and D. A is the most mild climate, and that would typically be seen out in Vancouver, Victoria, maybe southern Ontario. B is the next up in Saskatchewan. Places that would be in Zone B would be like Maple Creek, Swift Current, Moose Jaw, Estevan, stuff like that. Most of the province is in Zone C for Saskatchewan. That would include Regina, Saskatoon, and even Prince Albert. And only the most severe climate in the northeast would be in Zone D. The A, B, C, and D zones are based on either energy rating of the windows or their U and R value. And that's what determines what zone a particular location is in. Okay? And the more severe the zone, the better the window needs to be. The higher the U value, or the lower the U value, the higher the R value needs to be for that window to be acceptable for that particular zone. So again, going to high efficiency windows makes a lot of sense. The nice thing about windows, compared to all the other components in our house, all the other components are a dead energy loss, right? You lose energy through your attic, you lose it through your walls, it's just gone. The nice thing about windows is they don't have as high an R value as the walls, and so you do have a fairly high heat loss, but the nice thing about them is that they have a solar gain or heat gain. And you can get windows that actually gain more than they actually lose depending on where they're located and the specs and stuff like that on the windows. So that's kind of interesting. It's one of the only component in our building envelope where there's actually gains. There's losses, but there's also gains. And so those gains can offset the losses and sometimes be more than the losses. So that's kind of interesting. So you can really tweak your design to take advantage of that. 10 is reduced air leaks. As I indicated, with all of these new housing programs, we air test, do a blower door test on each and every house. And there's a CGSB standard for doing the air test, and the results of that test are input into the software, and the software then does a simulation as to what the normal leakage would be. And it then calculates an energy load or a heat load based on what that natural leakage is. And this house here, I'm sure is going to be super tight, but when you look at some of these older houses out there, the benchmark for Energy Star for new homes is 2.5 air changes at 50 pascals. This house will probably be down under 1, I'm thinking. We haven't, when push comes to shove, we'll find out once it gets on its permanent foundation, I guess, right? The benchmark for R2000 is 1.5 air changes. In the retrofit program that we also do, we've had houses that have tested at 20 air changes an hour. It's almost like living in a carport with no walls in it or no granary, right? They can, and that's just a huge energy consumption, but it's also very uncomfortable for the occupants because of the drafts and everything else like that that's going on. So, you know, one of the benefits of very low air leakage or better air tightness is you save energy, but there's also other things. You protect the building envelope so you don't get moisture leaking into the building envelope, condensing and causing deterioration. You stop the drafts for customers so that the homeowners are there and they're nice and comfortable sitting by a window while they're watching television or whatever the case might be. So air leakage has an energy component, but it's also got a comfort associated with it as well. A couple more quick things is on the electrical side, putting in efficient lighting, putting in efficient appliances, air conditioners and things like that, which are not only important for reductions in the electrical grid that we've got out there, but again, energy savings. And these days we're going to CFL lighting, we've got LED lighting, which this house has quite a bit of, I think. We have very high efficiency appliances as far as dishwashers and refrigerators. You could look at the Energy Star air conditioners, which have a SEER 14. SEER is Seasonal Energy Efficiency Rating. Most of the old ones used to be in that 10 to 13 range. The current standard for Energy Star for air conditioners is SEER 14.5, and that's probably going to be going up in the future. And finally, it's third-party verification, which is what Sunridge does, is we come in and we're not a builder, we have no vested interest in passing any house or failing it or anything else like that. So we do an independent energy analysis, we do the software verification, we do the site verifications, checking for make and model numbers and Energy Star qualifications. We do the air tightness testing, we submit all the files to Ottawa and that type of thing. So that third-party verification is quite important because otherwise, how do you know what you've got? Anybody can go out there and build a house and say, well, I've got a high-efficiency furnace, I have a highly efficient house. Well, that's only one little piece in the whole puzzle. It's the whole concept. Everything sort of ties together and interacts with each other as far as the insulation and the walls and the attic and the mechanicals and the air leakage and everything else like that. Okay? So that's the basic components of an Energy Star house. But that applies to existing houses and it applies to the equilibrium houses as well. It's just to what degree the insulation is and the air tightness and the equipment efficiency is. Okay? The Energy Star houses need only Energy Star trained and licensed builders can build Energy Star houses. And you get licensed by Natural Resources Canada. So you have to go through a training program here in Saskatchewan, which Sunridge does. And then once the builders have gone through that, the information is done up and sent to Ottawa, and then there's a licensing agreement between Natural Resources Canada, between the federal government and the builder, once they've shown that they've taken the courses and they can go ahead and do that. Only trained and licensed R2000 builders can build R2000 houses. We can also do a third program that I mentioned was EnerGuide for New Houses rating system. And any house can be done that way. So whether it's a builder, whether it's a homeowner building their own house or whatever it happens to be, and it's simply a rating. You don't have to be trained. You can take an existing house that's just been finished being built, we go in there, we model it, we get all the details about it, and so the things like the duct sealing and the Energy Star windows and things like that don't apply to that, but all you get then is just the rating. The house rates a 72 or 95 or whatever it happens to be on that magical rating scale from 0 to 100. So we can, from a rating perspective, we can rate any new home out there. But only registered and licensed builders can build Energy Star for new homes or R2000 homes. Okay? Here are some of the benefits of Energy Star homes. One is lower ownership cost. Obviously that seems like it's pretty evident, but The more efficient your house is, the less natural gas you have to buy, and usually the less electricity you need to purchase as well. So your monthly cost for utilities are down because your house is that much more efficient. Something else I mentioned there about air leakage, and that's the number 2 on here, and that's a higher level of comfort. You have less temperature stratification in a well-built house like an Energy Star house. You have less drafts coming in through natural leakage through your walls and your electrical outlets around your windows and doors and whatever else you've got there. And so it's just a more comfortable house to live in. You have quality assurance by having a third party independently verify that it's been built to a standard. Because like I said before, somebody can put in high efficient windows or a high efficiency furnace and they say, yeah, it's good to go. Well, how leaky is it? Is it tight or is it loose? What's the efficiency of it overall? So that's another benefit. The fourth thing is health and fresh air. And this is what many of the people that are living in Energy Star or R2000 houses will say. And until you live in it, you don't know what you're missing, I guess, is the key word. Is because both of these kinds of houses need to have all houses need to have ventilation systems meeting the code, but it's only Energy Star and R2000 houses that need to have heat recovery ventilators in them. And because heat recovery ventilators save energy, but more importantly, they're a very efficient and powerful ventilation system, the homeowners tend to use them all the time. They're designed to run 24 hours a day. And you always have a low level of mechanical ventilation, and then when you need it, you can kick it up into high, and you get additional if you're showering or cooking and other things like that as well. And because it's got lots of power behind it, it can move more air, and because it's in the basement, it tends